The Case 504 diesel engine, which was intended to provide greater torque, durability, and operating hours than earlier versions, was unveiled as the flagship of Case's new generation of potent tractors in the late 1960s. The 504 was once hailed for its powerful torque and seamless operation, but it soon gained a bad reputation for serious problems, including overheating and mechanical breakdowns in actual farming settings, which almost destroyed Case's standing in the agricultural industry. An overview of the 504 diesel disaster, the engine that nearly broke Case, in 10 points is provided here. Number 10. Ambitious launch. In the early 1970s, Case faced mounting pressure to innovate as competitors like John Deere and International Harvester were introducing increasingly powerful and reliable tractors. Farmers demanded machines that could handle larger acreage and heavier implements without frequent breakdowns. In response, Case designed the 70 series tractors, which were bigger, sleeker, and more powerful than anything in their lineup before. Central to this push was the new 504 diesel engine, a straight-six powerhouse with a displacement of 504 cubic inches, 8.3 liters. The engine was intended to deliver high torque at low RPMs and, in turbocharged versions, over 150 horsepower, enough to compete with the best in the market. Case marketed the 504 as a revolutionary engine that would usher in a new era of durability, power, and efficiency, promising farmers a reliable workhorse capable of enduring long, hard hours in the field. This ambitious launch was critical for Case to maintain its market share and relevance in a rapidly evolving agricultural industry. Number 9. Innovative but risky design. The 504 diesel engine featured a mid-sleeve block design, which was a departure from the traditional wet sleeve engines used by competitors. Instead of fully separate wet sleeves, the 504 used partial sleeves bonded directly into the engine block casting. This was intended to improve heat transfer and reduce distortion under heavy loads, theoretically enhancing durability and cooling efficiency. The engine also employed a simple mechanical fuel injection system and a straightforward turbocharger setup, designed to make servicing easier for farmers and independent mechanics without requiring specialized tools. However, these innovations introduced new vulnerabilities. The mid-sleeve design made the block highly sensitive to coolant chemistry and maintenance. Improper coolant management could lead to cavitation erosion, where vapor bubbles violently damage the cylinder walls from inside, a problem less common in traditional wet sleeve engines. Additionally, the oiling system, while adequate for moderate use, struggled under extreme conditions, leading to premature wear of bearings and cam components. These design risks were compounded by insufficient real-world testing before mass production, leaving the engine vulnerable to failures that would soon emerge in the field. Number 8. Major reliability issues. Once deployed, the 504 quickly developed a notorious reputation for reliability problems. Farmers reported early failures such as cracked cylinder heads, blown head gaskets, and bearing wear, occurring as early as 1,700 to 2,000 hours, well below the expected lifespan for a tractor engine. The engine's mid-sleeve block was particularly vulnerable to cavitation erosion, which could silently eat through cylinder walls, causing catastrophic engine failure. Head gasket failures were common, often resulting in coolant leaks that led to overheating and warped heads. These issues frequently necessitated complete engine rebuilds or replacements, which were costly and time-consuming. The reliability problems were especially frustrating because the engine had been marketed as a durable, heavy-duty solution. The combination of mechanical weaknesses and thermal management failures meant that many farmers faced repeated breakdowns during critical farming seasons, eroding confidence in the engine and Case's products. Number 7. Overheating problems. A major contributor to the 504's failures was its tendency to overheat under heavy workloads. The mid-sleeve block design, while intended to improve cooling, required precise coolant chemistry and maintenance to prevent cavitation erosion. If coolant was not properly maintained, vapor bubbles formed and collapsed against cylinder walls, causing internal damage. The engine's cooling system struggled to dissipate heat generated during prolonged or intense use, especially in turbocharged versions that pushed the engine harder. Overheating caused thermal expansion and warping of cylinder heads and gaskets, accelerating failures and often leading to catastrophic damage. Additionally, overheating degraded lubricating oil effectiveness, increasing wear on bearings, cam lobes, and rocker arms. This created a vicious cycle where heat-induced damage led to mechanical failures. Number 6. High maintenance costs. The 504s. Complexity and the nature of its failures led to high maintenance and repair costs for farmers. The engine's large size, mid-sleeve block design, and specialized components meant that repairs often required skilled mechanics familiar with its unique construction. Replacement parts were not always readily available in rural areas, leading to extended downtime. Repairs like line boring worn cylinders, replacing cracked heads, or addressing cavitation damage were labor-intensive and expensive. The high cost of maintenance, combined with frequent breakdowns, placed financial strain on farmers who relied on their tractors for essential seasonal work. Downtime during planting or harvesting could cause significant losses, making the 504's maintenance challenges more than just an inconvenience. They could threaten the viability of farming operations. Number 5. Damage to Case's reputation. The 504 diesel engine's failures had a profound impact on Case's reputation in the agricultural community. Farmers who had trusted Case for dependable equipment were disillusioned by the engine's unreliability and costly repairs. Negative experiences spread quickly through word of mouth and farming forums, damaging Case's brand loyalty at a time when competition was fierce. The backlash forced Case to respond with increased warranty support, customer service efforts, and engineering revisions to address the engine's flaws. Despite these efforts, the 504 episode remained a black mark on Case's history, illustrating how a single product failure can erode customer trust and market position. It also highlighted the risks of prioritizing innovation and power without sufficiently validating durability and reliability under real farming conditions. Number 4. Long-term impact. The 504 diesel disaster became a pivotal learning experience for Case. The company undertook a comprehensive review of its engineering, testing, and quality assurance processes to prevent similar failures in the future. Subsequent engine designs incorporated more rigorous durability testing, improved cooling systems, and better materials to withstand the stresses of heavy agricultural use. While the 504 nearly broke Case's reputation, the company's ability to adapt and improve helped it recover over time. Farmers who learned the engine's quirks and maintenance needs could extend its life significantly, and some 504-powered tractors remain in use today. The legacy of the 504 is a reminder of the importance of balancing cutting-edge innovation with thorough validation and practical field experience before introducing new technology to demanding markets like agriculture. Number 3. Sensitivity to coolant chemistry and cavitation erosion. One of the most insidious problems with the 504 diesel engine was its mid-sleeve block design, which made it extremely sensitive to coolant chemistry. Unlike traditional wet sleeve engines used by competitors like John Deere and International Harvester, the 504's sleeves were bonded into the block casting. This design required precise maintenance of coolant additives, specifically supplemental coolant additives, to prevent cavitation erosion. Cavitation occurs when vapor bubbles form and violently collapse against the cylinder walls under heavy load, gradually eroding metal from the inside out. This silent destruction was often undetected until catastrophic failure occurred, such as holes punched through cylinder walls. Farmers unfamiliar with this vulnerability were caught off guard, as the engine could appear externally sound while suffering severe internal damage. Number 2. Operator technique and engine management, crucial for longevity. The 504 engine's performance and durability were heavily influenced by how it was operated and maintained. Unlike older, low-speed diesels, the 504 thrived at moderate RPMs where airflow and coolant circulation were optimal. While none of these practices made the 504 indestructible, they significantly improved its survivability and extended service life in the hands of knowledgeable farmers and mechanics who adapted to its quirks. Number 1. Case's response and impact on customer trust. As failures and warranty claims mounted, Case engineers scrambled to address the 504's weaknesses by introducing revised head gasket materials, updated torque specifications, and improved water pumps to enhance cooling. This story exemplifies how an innovative engine design, promising on paper, can falter under real-world agricultural demands, nearly breaking a company's reputation in the process. If you liked our video, please hit the like button and subscribe to our YouTube channel.